According to the National Electrical Code, specifically Table 250.122, the equipment grounding conductor size for alternating current services is determined by the size of the service entrance conductors. In the given scenario, a 200 amp service is supplied by 3/0 American wire gauge copper conductors. To determine the proper size of the equipment grounding conductor, one must refer to Table 250.122. This table correlates the size of the service entrance conductors to the minimum required size of the equipment grounding conductor. For service entrance conductors ranging from 3/0 through 300 kcmil, the minimum size for a copper equipment grounding conductor is number 4 American wire gauge. Therefore, a number 4 American wire gauge copper conductor or larger is the correct size for the equipment grounding conductor in this situation. It is crucial to ensure that the equipment grounding conductor is properly sized to provide a low impedance path for fault current, which facilitates the operation of overcurrent protective devices such as circuit breakers or fuses. This helps to minimize the risk of electrical shock and equipment damage. Installing an undersized equipment grounding conductor can compromise the safety of the electrical system. The table specifies minimum sizes, so using a larger conductor is always acceptable. However, using a smaller conductor is a violation of the National Electrical Code and presents a safety hazard. The equipment grounding conductor plays a critical role in the overall grounding and bonding system, which is designed to protect people and equipment from electrical faults. In addition to the equipment grounding conductor, the grounding electrode conductor connects the grounded conductor, typically the neutral, to a grounding electrode, such as a ground rod or a metallic water pipe. The size of the grounding electrode conductor is determined by Table 250.66, which is different from Table 250.122 used for equipment grounding conductors. It's important to differentiate between the two types of grounding conductors and use the appropriate table for each. Ensuring that all grounding and bonding connections are properly made and that the correct conductor sizes are used is essential for a safe and reliable electrical system. The equipment grounding conductor provides a path for fault current to return to the source, allowing the overcurrent protective device to trip and clear the fault. This minimizes the duration of the fault and reduces the potential for damage or injury. Proper grounding and bonding also help to reduce electrical noise and improve the performance of sensitive electronic equipment. When installing or inspecting an electrical service, it is important to verify that the equipment grounding conductor is properly sized and installed according to the requirements of the National Electrical Code. This includes checking the conductor size, the connections at both ends, and the overall condition of the conductor. Any deficiencies should be corrected immediately to ensure the safety and reliability of the electrical system. Furthermore, understanding the different types of grounding conductors and their respective roles is crucial for anyone working with electrical systems. The grounding electrode conductor connects the grounded conductor to the grounding electrode system, while the equipment grounding conductor provides a path for fault current back to the source. Both types of conductors are essential for a safe and effective grounding system. When working with electrical systems, always consult the latest edition of the National Electrical Code and follow all applicable safety procedures. Electrical work can be dangerous, and it is important to be properly trained and qualified before attempting any electrical installations or repairs. In summary, for a 200 amp service with 3/0 American wire gauge copper service entrance conductors, a number 4 American wire gauge copper conductor or larger is required for the equipment grounding conductor according to National Electrical Code Table 250.122. Adhering to these code requirements is essential for ensuring a safe and compliant electrical installation. Always refer to the latest edition of the National Electrical Code and consult with a qualified electrician if you have any questions or concerns about grounding and bonding requirements. Electrical safety is paramount, and it is crucial to follow all applicable codes and standards to protect people and property from electrical hazards. Remember to always de-energize electrical circuits before working on them and to use appropriate personal protective equipment such as insulated gloves and safety glasses. Following safe work practices is essential for preventing electrical accidents and injuries. Grounding and bonding are fundamental aspects of electrical safety and should be thoroughly understood by anyone working with electrical systems. By following the requirements of the National Electrical Code and implementing proper grounding and bonding techniques, you can help to ensure a safe and reliable electrical installation. Remember that the information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer for specific recommendations regarding your electrical system.